In this example, we're going to look at how to apply a chi-square test to some crash data. So we have some observed data from 2011 to 2015. These are fatal crashes that occurred in North Carolina, and specifically we're looking at the relationship between crash severity and seatbelt usage, and we're focusing on the rear seat, so those individuals in the rear seat. So in this 2x2 table, we have a column for individuals in this 5-year time period who were in the rear seat and not restrained with a seatbelt, or not properly restrained. So we had 273 individuals who were involved in a fatal crash, meaning at least one occupant of at least one of the vehicles in a crash was killed. So 273 individuals in the rear seat who were not properly restrained are included in this data set. Of those 273 individuals, 209 were killed, and there were 64 survivors. In our column for the properly restrained rear seat occupants, so these are people who were in the rear seat of a vehicle that was in a fatal crash in this 5-year time period, totaled 962 individuals. Of those 962, there were 344 individuals who were killed and 618 who survived that crash. Overall, there were 553 fatalities. So these are people in the rear seat of a vehicle in this 5-year period who were killed, and 682 survivors, for a total of 1,235 individuals in a fatal crash in the rear seat in this 5-year time period. Before continuing on with our analysis, it might be useful to just take a look at our data and see if we can learn anything just by looking at these relationships. So let's take a look at our data. So looking at the individuals who were in a fatal crash and not restrained, we see that there were 209 fatalities out of the total 273 individuals in fatal crashes. And so that's a percentage of approximately 77% who were killed, who were not properly restrained in the rear seat of a vehicle that was involved in a fatal crash. If we compare that to our individuals who were properly restrained, we'll see it's a much lower percentage. Only 36% of those who were in the rear seat and properly restrained in a fatal crash were killed during that crash. So this just helps set up our expectations for running this test. It looks like there is a big difference looking at the distribution of fatalities and survivors when we're comparing those who were not properly restrained and those who were properly restrained in a fatal crash. Now that we've taken a brief look at this data, we'll continue along with our analysis. And generate our expected value so we can perform our chi-square test. So to generate expected values, we need to multiply the row total by the column total and divide by the overall total. We can do this for each cell. And this will generate our entire expected values table. We are now distributing those 1,235 individuals as we would expect them in those 4 categories. And with this, we can now move on to determining our chi-square statistics for each individual cell, and then our overall chi-square statistic and our p-value to make a conclusion about this data. Now we can generate our chi-square statistics for the individual cells and then for the overall test. For an individual cell, we're looking at the difference between our observed counts and our expected counts. We're going to square that difference and then divide by our expected counts. We're going to get fairly large chi-square values for each of these cells, representing that our expectations were much different than our observed values. Our overall chi-square statistic is very large, 143.14. We could use a lookup table to determine the appropriate or approximate p-value for this test, or we can use the Excel function chisq.test, chi-square test. For this, we're just going to select the actual data and then with a comma separate it from the expected counts, and we're going to get a very small p-value here, very close to 0. Summarizing our null hypothesis, we're going to look for our null hypothesis is going to be that there's no difference in the distribution of fatalities and survivors with the two seatbelt treatments in the rear seat, those who are non-restrained and those who are properly restrained, compared to our alternative hypothesis that there is a difference. So our very small p-value leads us to reject the null hypothesis. So this suggests that there is a difference in the distribution of fatalities and survivors with the two rear seatbelt treatments, not properly restrained and properly restrained. So there is a statistically significant difference between these two categories and their distribution of fatalities and survivors.